Hello everyone. I again welcome you all on my YouTube channel. So the topic of today's video is we are going to discuss some of the problems associated with the initial GAN networks. Nowadays there are too much refinements and there is a lot of versions of the GAN available in the market. So some of the problems which I am going to discuss in this particular video is already solved by some other latest version of the GAN. But in our today's video, what we are going to discuss is we are going to discuss a problem which are associated with the initial GAN, because right now we are only discuss on the initial level of GAN which discussed by the good fellow in the year of 2014 and 15. So let's start our discussion. Before starting our discussion, let's quickly recap what we'll discuss in our previous video is. So in our previous video, we'll discuss on the topic of GANs, like we discuss the intuition behind GAN, and then discuss about some of the mathematical terms related to the GAN, and then finally going to discuss about this mathematical terminologies and objective function of loss. So this is a loss function of the GAN networks. So when we are talking about the GAN, what we'll have is we have two players. One is a generator and second one is a discriminator. What is the task of generator? Create a good quality of fake data, means generating a good quality data which is actually fake but it looks like real. And what is the task of discriminator so far? The task of the discriminator is to identify between real and fake. So it is nothing but a binary classification. These things we already cover up in our previous GAN video. And then what we'll discuss is we discuss loss function. So in this our GAN network, we have basically two neural network. First neural network is which neural network? One is discriminator. Discriminator is a classifier, binary classifier, and the second neural network is generator. So for two neural networks, it is obvious that we have to calculate an objective function or loss function for these both neural networks. So the loss function corresponding to the discriminator loss function is not minimize. When we are calculating loss in terms of the discriminator, so for finding optimal parameter, best parameter of discriminator, what we are doing is maximize the loss function. And what is the value of loss function is this expectation of x comes from p data of x, means this is the real data, log of d of x plus expectation of z is belong from p of z, means this is our estimated distribution. What is this? Log of log of 1 minus d of g of z. This is the loss function corresponding to the discriminator. When we're talking about the generator, so in generator what we are doing is we are performing a minimization, means minimize generator and the loss function. So if you remember, we write this common loss function. So when we are talking about the discriminator, then this both two terms, term number 1, term number 2 are associated, and talking about the generator, only this second term is associated. So loss function corresponding to generator is E of z belong from P of z log of 1 minus d of g of z. This is a loss function corresponding to discriminator. So the first problem which we are going to discuss in this video is vanishing gradient problem. Vanishing gradient problem. If you all are familiar with the vanishing gradient problem, like what is a vanishing gradient problem and how it is happening in a neural networks and all. So if you are not familiar with vanishing gradient problem, please look into these things and then come on that particular video. If I am going to discuss about the vanishing gradient problem in very quick manner, so vanishing gradient problem in basically what we'll have is, so due to our long term dependency or long term change. So if in a neural network we are calculating a too much partial derivative, so we one term is dependent on too many terms, like O4 is dependent on O3, O3 is dependent on O2, O2 is dependent on O1, and then O1 is dependent on O0 and X0. So basically there is a chain of gradient, and if these all gradient values are too much small, then if you multiply too much small values together, then your final multiplication output is near to zero. So while calculating a gradient, we are just multiplying partial derivative, and if there are too much small values, so a gradient is eventually too much small, and due to this, in our gradient descent algorithm, W new is equals to W old minus learning rate times gradient. If this is near to zero, and then this particular term is also close to zero. Due to this particular terms close to zero, the Wn is almost similar to W old, means new value and old value almost similar रहेंगे. So इसका मतलब क्या होगा कि no weights update happen, no update in weights. कोई weights update नहीं होगा तो neural network train ही नहीं होगा, and that's a problem of vanishing gradient. So let's discuss how vanishing gradient problem occurs in our generative adversarial networks GAN. So while training of I'll just discuss before a few minutes. So while training of discriminator, this is our loss function, but for generator, this is a loss function. So when we are training about the discriminator, everything goes fine and there is not an issue. But when we are training a generator, we'll have a problem of vanishing gradient. So training of the generator, we have vanishing gradient problem. Let's discuss how it is happens. So we are just taking an intuition of it. So this is a loss function corresponding to generator, and if you remember, we already plot the loss graph of this particular equation, and this was this particular graph. So this is a graph corresponding to this particular loss function. This x-axis denotes the value of d of g of z, y-axis is nothing but the output corresponding to this entire term, and let me missing a log of, okay, yes. So what we'll want is we have to minimize this term. Why we are minimizing this? Because what we want, this is a loss function corresponding to generator. This is a what probability of discriminator which is given for a generated data of generator. जनरेटर ने जो डेटा बनाया उसको डिस्क्रिमिनेटर ने क्या किस कैटेगरी में क्लासीफाई किया, मीन्स फेक में क्लासीफाई किया या रियल में क्लासीफाई किया. सो जनरेटर तो क्या चाहता है कि मैं जो भी डेटा बनाऊं डिस्क्रिमिनेटर उसको रियल बोले, ताकि मैं डिस्क्रिमिनेटर को उल्लू बना पाऊं. जनरेटर का काम क्या है? डिस्क्रिमिनेटर को उल्लू बनाना. सो व्हाट जनरेटर वांट इज the generated data corresponding to generator, which is g of z, is classifying by discriminator as a real images, means 1 means real images. एक्चुअल लेबल उसका जीरो ही रहेगा. देखिए दो टर्मिनोलॉजी है. अगर आप वाइल ट्रेनिंग जनरेटर ऐसा डेटा बना देता है कि जिसको डिस्क्रिमिनेटर फेक बोलता है, तो वो उसका प्रेडिक्टेड लेबल हुआ. बट व्हेन वी टॉक अबाउट द रियलिटी, जो एक्चुअल लेबल y होता है, y प्रेडिक्शन भले ही 1 हो, बट जो रियलिटी होती है वो तो चेंज नहीं होती. भले डिस्क्रिमिनेटर अभी उल्लू बन गया है जनरेटर से, बट रियलिटी होती है. मतलब डिस्क्रिमिनेटर का जो जनरेटर जो डेटा जनरेट करेगा वो एक्चुअली में उसका एक्चुअल लेवल तो जीरो ही कहलाएगा. अब कोई एक बंदा उसको 1 बोल रहा है, वो उसकी मिस्टेक है. यू अंडरस्टैंड व्हाट आई एम ट्राइंग टू से? सो एक्चुअल लेवल करस्पॉन्डिंग टू द जनरेटेड डेटा इज ऑलवेज जीरो. आई एम नॉट टॉकिंग अबाउट द प्रेडिक्टेड लेवल्स. एक्चुअल लेवल करस्पॉन्डिंग टू जनरेटेड डेटा इज ऑलवेज टू बी जीरो. So by considering these terms, let's start discussion further on it. So what we eventually want is the probability, this entire term, what we are ultimately we want is this entire term become 1. Because what is this? If you are remember, then in our GAN network, this is a discriminator. So there is a 2 channel. Here is x is coming, which is real, and g of z, which is generated by the generator, is also coming. So like here is a generator, here is a z, and here is g of z. So discriminator have two probabilities. One is d of x, and due to this d, if you have passed g of z to here, then we have d of g of z. So in term while in terms of generator, what we want is this value becomes 1. So this is our expectation. दिस इज नॉट रियलिटी राइट नाउ. दिस इज आवर एक्सपेक्टेशन कि डी ऑफ जी ऑफ जेड का वैल्यू 1 हो जाए. ये अभी हुआ नहीं है. हम चाहते हैं कि डी ऑफ जी ऑफ जेड का वैल्यू 1 हो जाए. बट वॉट एक्चुअली हैपन्स इज, लेट्स डिस्कस अबाउट इट. एक चीज होती है कि एक्सपेक्टेशन वर्सेस रियलिटी. सो लेट्स डिस्कस अबाउट द रियलिटी. एक्सपेक्टेशन अपनी थी कि डी ऑफ जी ऑफ जेड की वैल्यू 1 हो जाए. बट व्हाट्स हैपन हियर इज, सो एट द इनिशियल स्टेज when we are talking about this generator, at the initial stage this generator is generating very low quality data. So this is initially what will happen is this data is very low quality data. So what happen is it is easier for discriminator to classify in real and fake. Understand? So initially what happen is data generated by the generator is very low quality, means this is not looks realistic data set. So if anyone can look into this, they can easily say that this is a fake data set. So what happen is, if anyone can say, then discriminator is also able to classify in between real and fake. So initially what happen is, this is a probability corresponding to the generated data. This is a probability corresponding to the generated data. And in the initial epochs, let me write with the different color. In initial epoch, these d of g of z are close to 0. Why 0? Because it is a fake, means close to 0 means in the initial epoch this probability of fake is high. For fake की probability high मतलब इसका corresponding लेबल क्या आएगा, 0 आएगा. ठीक है, हम चाहते हैं 1 हो जाए, पर 1 हो नहीं रहा है. इनिशियल इपॉक्स जनरेटर अच्छे से डिस्क्रिमिनेटर अच्छे से ट्रेन होगा, बट जनरेटर उतना अच्छा डेटा जनरेट नहीं कर पा रहा होगा. तो जनरेटर क्या बोलेगा, ये इसको ईजिली बोल देगा कि है ये तो फेक डेटा है, दिस इज नॉट अ रियल डेटा. ठीक है, अच्छा डेटा फिर से जनरेट करके आओ. सो इस पर प्रॉब्लम क्या है, आप देखिए. इनिशियली हम चाहते हैं कि 1 हो जाए मतलब ये वैल्यू हो जाए. ये हमारी एक्सपेक्टेशन है कि 1 हो जाए. इनिशियली ये हो क्या रहा है, 0 हो रहा है, मीन्स यहाँ के आसपास यहाँ हो रहा है ये. अब इफ़ यू रिमेंबर, वी डिस्कस इन आवर प्रीवियस वीडियो दैट इन दिस पर्टिकुलर ग्राफ we are not considering these portion, because since it is a probabilistic value, so we'll only have domain in between range of sorry, let me use another color. So our domain is restricted from 0 to 1, means 0 to 1 की एरिया में जितना ग्राफ आएगा उतना ही रहेगा. सो फाइनल आवर कंसिडरेशन ऑफ ग्राफ कितना था, दिस एरिया ओनली, इतना एरिया अपना ग्राफ का कंसिडरेशन था. सो इफ यू केयरफुली लुक इन दिस पर्टिकुलर ग्राफ, so let me just remove all of these things. Let me draw this graph again here. So I'm only drawing a area of consideration for this particular graph. So if we draw this graph here, then this is our actual graph after removing the unnecessary graph. This point is 1 and this is our actual graph. So if you are going to discuss on this, what is this is your y value and this is d of g of z. So in the initial state, d of g of z becomes 0. In initial epoch, d of g of z becomes 0. So it is initially it is 0. And if you can draw a slope, what is the value of derivative? This is a very basic thing which already you can study in your 10th or 12th class. So the derivative at that particular point, derivative जो अपना derivative होता है is equals to slope. डेल्टा और slope दोनों एक ही बात है. So what is a slope? What is a derivative? Slope at that particular point, it is a derivative. This is all you know. So if let's say consider these type of graph. So if I'm talking that what is a derivative at that particular value, then you can easily say that the slope value at that particular point is my derivative value. What is a slope? Derivative is equal to slope. Derivative and slope value are almost these both two are equal. And what is a slope? Tangent at that point. So initially for calculating derivative, what we are eventually doing is calculating slope, and slope means tangent. We are drawing a tangent to find the slope. So if you are drawing a tangent at this particular point, so this is becomes like this. And if you can see, this is near to 0. This will near to 0. Why? Because at that particular point your derivative becomes 0. That at particular point your derivative becomes 0. So because of this, what's happen is, in our loss function, let me again remove this portion. In our loss function, we have these. Let's only write these terms only. Log of 1 minus d of g of z, right? And initial base पे ये क्या होगा, ये 0 हो जाएगा. So log of 1 minus 0 is equals to log of 1. Log of 1 is what? Log of. So initially what's happened is this, and this log of 1 is becomes, this log of 1 becomes 0. So no feedback provided to the previous generator. And if you can observe in this particular graph, then if there is also the initial derivative value which I just discussed is the slope at that particular point, and this slope is becomes 0. This slope is becomes 0 at that point. So due to this we have a vanishing gradient problem. मैंने अभी just discuss किया कि vanishing gradient problem क्या होता है. So ये slope 0 हो जाएगा तो eventually weights update नहीं होंगे, because why delta is 0 and learning rate is, you also know that this is a quantity like 0.1, 0.01 and all. So eventually if you subtract these from some numbers of W old, then eventually whatever you getting is W new, and this W new and W old are almost similar. I mean, no weights update happen, no feedback is provided while the back propagation, and it's eventually cause a problem in the training of our entire GAN networks. So this is a vanishing gradient problem. Let me discuss कि how we can solve this particular problem. So initially हम लोग क्या कर रहे थे, this is our loss function. We convert this loss function in other form. So from this particular loss function, what we are doing is, again, how we can convert from one loss function to other loss function, which I am not going to discuss in this particular video. But instead of minimize this particular equation, instead of minimize this, what we are doing is, let me write here, minimize g, expectation is there, z come from p of z, negative of log of d of g of z, and this is a corresponding to generator. So instead of these, minimizing this term 1 minus d of g of z, if I compare here, instead of minimize this log of 1 minus d of g of z, what eventually right now we are doing is minimize g, but what is this particular equation, minus log of d of g of z, minus log of d of g of z. So if you can plot a graph of d of g of z, then it is look similar like this. Let me use this. So if you have plot a graph of log of d of g of z, means log of x almost. So if you are plotting this particular graph, then this is look like this. So this is looks like graph of log of x. Log x graph looks like this. Better. Log x graph is look like this. This is a 1, and again this area we does not consider this area because we only consider this particular range area. So at initial points, now in this graph what's happen is initially our d of g of z is become 0. In this particular graph also we have d of g of z here, but what changes, instead of these loss function, right now we are using this particular loss function. So what happened here is ki like here it is initially become 0, and initially if it is become 0 then their slope value is also 0. Here it is also d of g of z is also initially become 0, because initially जो जनरेटेड डेटा के करस्पॉन्डिंग प्रोबेबिलिटी आएगी उसमें आउटपुट ये आएगा कि ये फेक डेटा है, क्योंकि जनरेटर सही से ट्रेन नहीं हुआ होगा उतना अच्छा डेटा जनरेट करने के लिए. So if initially here it is become 0, then it is also near here 0 or near to 0 and somewhere lies here. And if you calculate the slope means tangent at that particular point, then you have some significant value in your tangent. Looks like, देखो, I'll draw a tangent at that particular this particular point. इस particular point पे अगर मैं tangent draw करूँगा, initially ये 0 पे रहेगा तो. So we have some significance value of slope. So initially we don't have delta not become 0 or not close to 0. So initial stage में weights update होगा, and due to this weights update चालू हो गए, that means no vanishing gradient problem, not at all. So you understand how we are discussing. Let's summarize quickly. Initially this is our loss function, but what is the problem? Vanishing gradient problem. Why? Because initially it is d of g of z becomes 0. Why it is become 0? Because generator is not trained well, and because of this not training well, the probability corresponding to generated data means output corresponding to generated data is always 0 by discriminator. Discriminator इसको आसानी से बोल देगा कि 0 होगा. If this becomes 0, then log of 1 minus 0 is equals to log of 1 and is equals to 0, means कोई feedback नहीं जाएगा. If you also or carefully look in the graph, then initial gradients are also 0, means slope initially is 0. So initial gradient 0 means vanishing gradient problem. So to solve this particular problem, what we are introducing is, now instead of these we are introducing these, minimize this particular loss function, and then this. So if you if you can look, then here then there is no initial slope is not equal to 0. So weights update is happen and everything goes fine. So this is the vanishing gradient problem in our GAN. So this is all about the vanishing gradient problem. Now let's discuss the second problem which is associated with the GAN. The second problem associated with the GAN is mode collapse. What is this problem? Before understanding the mode collapse problem, let's first try to understand what is a mode. So mode, I'll write definition here. The value which is occurring most frequently in a distribution is called mode. So if you look into this distribution, so if you can observe, then here we have this one, this and these three distribution. And what is the most frequent value? This is the most frequent value for this particular, this is the most frequent value for this particular distribution, and this is the most frequent value for this distribution. So if you can see, then this is a mode, this is again one mode, this is again one mode, and if we can give some name, then this is the mode number 1, this we can say mode 2, and this we can say mode 3. 3 modes in our data set. So at an extreme situation, so in the generator what's happen is, sometimes let's consider one example. Instead of generating all type of data, generator generates some of the sample or some of the classes of data. Instead of generating all type of data, generator generate only few of the type of data. So likewise, if you can see in this particular picture, if you can see in this particular picture, only this image again and again repeatedly comes in your generated outputs again. Eventually what you want is, you want that each time it generates some of the different images, different kind of images, likewise shown here in this picture. If you can observe this, then these all are the different. But what happened in the issue of mode collapse is, generator generating only some kind of classes or some, मतलब ये किसी एक डिस्ट्रीब्यूशन को पकड़ लेगा और उसी के अराउंड, उसी के इर्द गिर्द पूरा डेटा जनरेट करेगा. So this is a problem of the mode collapse. So let's start to discuss why it is happening and all. So if we can discuss about these, so data which is, if we can draw the probability distribution of the data, and let's remove this only type. So if this is a probability distribution of the real data, then this is the mode of this data m. And if you can say that the data close to the mode, in means data lies in between these range, are more realistic data. These are the more realistic data, most frequently happening data compared to this data. If this data point is D1 and this data point is D2, then D1 is what we can see is D2 is more realistic compared to D1. D2 is more realistic compared to D1. So what's happen is, initially let's take one example. So let's say you have a MNIST dataset. So in our MNIST dataset, we'll have 9 classes from 0, 1 up to 9. So real world dataset is multi-distribution, means multi-model dataset. So in general, in your dataset, you do not have like these only one bell-shaped curve, but in a real world dataset is multi-model. So if you can plot this MNIST dataset, then let's say this is a distribution corresponding to some class 1, this is distribution corresponding to second class, this is a distribution corresponding to some third class, this is also distribution corresponding to some other class. Let's for simplicity remove this. This is some other distribution, and likewise so on. So let's say this is a distribution of digit 0. This is a distribution of digit 2. This is, let's say, distribution of digit 7. This is a distribution of digit 4. Understand? So these all are the distribution corresponding to the different classes present in our MNIST data set. But what's happen is, so what यहाँ पर क्या होगा, जैसे आप समझिए थोड़ा, टास्क ऑफ डिस्क्रिमिनेटर इज व्हाट, डिस्क्रिमिनेटर का काम क्या है, रियल और फेक में क्लासीफाई करना। किसको, डेटा को, जो जनरेटर ने जो डेटा जनरेट किया वो रियल लग रहा है या नहीं लग रहा है। ठीक है, अब लेट्स से कि इनिशियली जनरेटर कुछ डेटा जनरेट कर रहा होगा, इनिशियली लेट्स से कि जनरेटर का डिस्ट्रीब्यूशन कुछ इधर के आसपास ऐसा होगा। ठीक है, फिर जैसे जैसे जनरेटर के वेट्स अपडेट होते जाएंगे, वो हम क्या मानेंगे कि ये अगर हमारा रियल डिस्ट्रीब्यूशन है, सो व्हाट वी एक्चुअली वांट इज हमारा जनरेटेड डेटा का डिस्ट्रीब्यूशन भी करस्पॉन्डिंग टू कुछ इसी के आसपास आ जाए, लाइक सो अगर हम इसी डिस्ट्रीब्यूशन में से कोई भी एक पॉइंट उठाएंगे तो वो भी प्रोबेबिलिटी एक को 0, 2, 4, 7 इन्हीं के जैसा दिखेगा। अगर हमारा जो ये रेड लाइन से लिखा हुआ है वो जनरेटर का डिस्ट्रीब्यूशन है आफ्टर ट्रेडिंग, अगर हम क्या चाहते हैं कि ये डिस्ट्रीब्यूशन भी मोरल और सिमिलर टू द रियल डेटा हो जाए, ताकि व्हेन वी आर यूजिंग द जनरेटर देन इट्स ऑल्सो जनरेट अ रियलिस्टिक डेटा विच इज लुक्स रियलिस्टिक बट नॉट एक्चुअली रियल। दिस इज वी एक्चुअली वॉन्ट इज, बट लेट्स अज्यूम कि यहाँ पर देखो कि जैसे कि 4 मोड्स है, मोड 1, मोड 2, मोड 3, मोड 4, और वी कैन से दिस 4 कर्व्स है अलग अलग। what if instead of learning these 4 curves, your generator only learns these 1 curves, only this distribution, let's say this is distribution of 2, digit number 2। अब क्या होगा, जनरेटर को 2 की इमेज बनाने में इसके पास महारत है अभी। जनरेटर इज वेरी गुड एट जनरेटिंग अ image of digit number 2, but it don't know how to generate an image of other digits like 0, 9, 7, 3। ये सिर्फ जानता है कि मुझे 2 कैसे बनाना है, आई नो। सो व्हाट्स हैपन इज 2 के ऊपर ये अच्छे से ट्रेन हो गया। अब जब ये 2 की इमेज व्हेन दिस 2 गोज टू द डिस्क्रिमिनेटर फॉर क्लासिफिकेशन, डिस्क्रिमिनेटर ऑल्सो गेट कंफ्यूज। वाई कंफ्यूज? बिकॉज जनरेटर ने इतना अच्छा इमेज बनाया है क्योंकि उसको सिर्फ 2 की इमेज जनरेट करने में उसको महारत हो गया है अभी। सो व्हाट्स इवेंचुअली हैपन इज कि डिस्क्रिमिनेटर को 2 ने डेटा दिया, अब डिस्क्रिमिनेटर ऑल्सो गेट कंफ्यूज और उसने 0.5 प्रोबेबिलिटी बोल दी, लाइक वाइज वी डिस्कस इन आवर लास्ट वीडियो कि डिस्क्रिमिनेटर कंफ्यूज हुआ मीन्स 0.5 प्रोबेबिलिटी बोल दी। और इंस्टेड ऑफ दिस इफ वी आर डिस्कस इन सिंपल वर्ड, सो इसने बोल दिया कि ये रियल डेटा है, मीन्स 1 बोल दिया डिस्क्रिमिनेटर ने। जब ये 2 इसको दिया, जनरेटर का जनरेट हुआ, डिस्क्रिमिनेटर से इट इज 1 मीन्स व्हाट हैपन इज डिस्क्रिमिनेटर बिकम्स फुल, बट सो डिस्क्रिमिनेटर तो फुल बन गया। अब ये जनरेटर भाई क्या हो गए, ये खुश हो गए। वाई इट इज हैप्पी, बिकॉज डिस्क्रिमिनेटर इज गॉट फुल, डिस्क्रिमिनेटर को इसने फुल बना दिया। डिस्क्रिमिनेटर को फुल बना दिया मीन्स डिस्क्रिमिनेटर का लॉस तो बढ़ जाएगा, बट जनरेटर का लॉस तो अभी वो तो खुश हो गया। सो व्हाट्स हैपन इज इंस्टेड ऑफ लर्निंग दिस एंटायर ऑल 4 मोड्स, instead of learning this entire all 4 modes, our generator only learn this particular mode and generator only similar 2 ही डिजिट जनरेट करेगा हर बार। लाइक वाइज मैंने बोला था कि हम चाहते गए कि ऐसी हमारे पास कुछ फेक डेटा जनरेट हो गया है, बट इंस्टेड ऑफ जनरेटिंग वेराइटी ऑफ फेसेस आवर जनरेटर इज ऑलवेज जनरेट अ सेम काइंड ऑफ डेटा लाइक शोन इन दिस। तो पर ये सेम काइंड ऑफ डेटा जनरेट करेगा, ये बहुत अच्छा जनरेट करेगा ताकि ये डिस्क्रिमिनेटर को फूल कर पाए। Right now we don't have any mechanism to check whether these 2 distribution are almost similar or not. Why because in the discriminator portion we are using a classification mechanism to estimate the probability distribution. We currently don't have any currently at that particular point. So in this particular initial gains we don't have any mechanism to check whether the gain is learning only one distribution और 2 और 3 मीन्स अगर इसमें 4 डिस्ट्रीब्यूशन है अलग अलग, सो अभी हमारे पास कोई ऐसा तरीका नहीं है कि जिससे हम ये पता कर पाए कि इसने इन चारों को सीखा या फिर इन 4 डिस्ट्रीब्यूशन में किन्हीं एक या किन्हीं 2 को सीखा और बाकी का इसने सीखा ही नहीं। सो अब क्या प्रॉब्लम होगा कि उसको फीडबैक नहीं जाएगा। अब इसने एक चीज़ सीख ली, यही जनरेट करता जाएगा और डिस्क्रिमिनेटर भी फुल बन गया, तो अपना काम हो गया, हमने ट्रेनिंग स्टॉप कर दी और अल्टीमेटली फीडबैक पीछे गया ही नहीं। फीडबैक पीछे नहीं गया मीन्स नाउ नो ट्रेनिंग इज हैपन, नो वेट्स अपडेट्स एंड ऑल आर देयर, और दोनों अपने अपने में संतुष्ट हो गए, यहाँ पर बात खत्म हो गई मामला। एंड दिस इज द प्रॉब्लम ऑफ द मोड कोलैप्स इन अवर गेन। सो दिस इज व्हाट डिस्ट्रीब्यूशन जनरेटेड बाय गेन नेटवर्क एंड दिस इज आवर ओरिजिनल डिस्ट्रीब्यूशन। सो लेट्स टेक and okay, so let's take one real more example. So let's say there is one musician, but for understanding this problem let's take one example. There was one musician. What is the task of this musician is produce music, प्रोड्यूस म्यूजिक। ठीक है, वंस क्या होगा कि लेट से इस म्यूजिशियन ने कोई सॉन्ग बनाया एंड दिस सॉन्ग गॉट हिट, राइट, बट दिस सॉन्ग गॉट हिट। एक म्यूजिशियन है, म्यूजिशियन का काम है प्रोडक्शन ऑफ म्यूजिक, उसने एक सॉन्ग बनाया और ये गाना हिट हो गया। अब क्या होगा, ही इज गॉट हैप्पी। वाई? क्योंकि उसका गाना हिट हो गया। People also happy. People are also happy. Why? Because उनको अच्छा गाना मिल गया। But in the right now world, in the dynamic world of today's, आप भी देखते हैं कि इंस्टाग्राम पे एक रील एक हफ्ता चलती है और फिर बंद हो जाती है। So after some time, लोग क्या चाहते हैं कि हमें कुछ नया मिले, हमें कुछ नया मिले। But problem is, इसने एक अच्छा गाना बना दिया, थोड़ी देर में लोग पहले जो खुश थे वो अब बोर हो गए इससे। बट व्हाट्स हैपन इज इसने अपने आप को अपडेट ही नहीं किया। क्यों? क्योंकि इसने एक बार लोगों को खुश देख लिया, मतलब ये संतुष्ट हो गया कि हाँ अच्छा चलो अब तो सब सेट हो गया, अब तो अपना हो गया। उस चक्कर में क्या हो कि इसने अपने आप को अपडेट ही नहीं किया, इसने अपने आप को कुछ नया सीखा ही नहीं। अभी लोगों को वैरायटी ऑफ द म्यूजिक चाहिए कि एक टाइप का म्यूजिक नहीं, उनको पार्टी सॉन्ग्स भी चाहिए। दे ऑल्सो लाइक रोमांटिक सॉन्ग्स, दे ऑल्सो लाइक डिफरेंट काइंड ऑफ सॉन्ग्स। तो आपको भी पता आना चाहिए कि आपको एक एज अ म्यूजिशियन आपको पार्टी सॉन्ग जनरेट भी करना आना चाहिए, आपको रोमांटिक सॉन्ग्स भी जनरेट करना आना चाहिए, आपको कुछ कुछ लोकल लैंग्वेजेस का भी आइडिया होना चाहिए, ठीक है। मीन्स यू हैव एबिलिटी टू जनरेट अ वेराइटी ऑफ द सॉन्ग्स, नॉट एक टाइप की। ऐसा नहीं कि पार्टी सॉन्ग जनरेट कर रहे हो तो सिर्फ पार्टी सॉन्ग ही आना चाहिए। सो आफ्टर अ सर्टेन पीरियड ऑफ टाइम लोग इससे बोर हो जाएंगे, बट इसने तो खुद को अपडेट ही नहीं किया। तो सेम प्रॉब्लम हैपन हियर्स। इनिशियली इसने एक ही डिस्ट्रीब्यूशन से डेटा जनरेट कर किया, तो इसके बाद से क्या हुआ, इसका वेट्स अपडेट ही हैपन नहीं हुआ, और इवेंचुअली फिर जो म्यूजिशियन होगा वो फिर शॉर्ट टर्म में वो इसका ख़त्म हो जाएगा पूरा। सो सेम प्रॉब्लम हैपन विथ गैन। गैन ने क्या किया कि एक डिस्ट्रीब्यूशन अच्छा बनाया, इसने पार्टी सॉन्ग ही अच्छा बनाना जानता था, बट सेम वे में इसको रोमांटिक सॉन्ग और सम अदर टाइप ऑफ म्यूजिक लाइक आवर कल्चर म्यूजिक एंड ऑल ये अच्छे नहीं बना पाता था। सेम हियर, एक डिस्ट्रीब्यूशन लाइक वाइज शो कि 2 डिजिट नंबर 2 ये बहुत बढ़िया जनरेट कर रहा था, बट 0, 4, 7 इस सब का इसको आइडिया ही नहीं था कि ये कैसे जनरेट करेगा। So this is a problem of mode collapse, and this is we cannot consider this training is eventually good, because what we eventually want is our output becomes looks like this, but actually output कैसा आ रहा है, ऐसा आ रहा है। तो हम ये नहीं चाहते, हम चाहते हैं कि डिस्ट्रीब्यूशन जो एक्सपेक्टेड डिस्ट्रीब्यूशन है वो भी ऐसा है, जो एस्टिमेटेड डिस्ट्रीब्यूशन है वो भी ऐसा है। तो दिस इज अ प्रॉब्लम ऑफ द मोड कोलैप्स। So because of this two-player game, it is very difficult to achieve a Nash equilibrium condition in our GAN. So in this particular क्या होगा कि अभी ये जनरेटर जो है इसको फ़र्क ही नहीं पड़ता कि डिस्क्रिमिनेटर का क्या है क्या नहीं है, ये अपना अलग ही गेम खेले जा रहा है, सिर्फ 2 2 2 2 हर बार 2 ही जनरेट करे जा रहा है, या फिर जो इसने लिमिटेड डिस्ट्रीब्यूशन लर्न किया है उसी के इर्द गिर्द डेटा जनरेट किए जा रहा है। मीन्स इसको फ़र्क नहीं पड़ता कि इधर क्या है क्या नहीं है। सो इट इज़ डिफिकल्ट टू अचीव अ नेस इक्विलिब्रियम इन द गेम। दिस इज अ थर्ड प्रॉब्लम ऑफ द पर्टिकुलर गेम, एंड दिस इज अगेन होमवर्क फॉर यू दैट यू हैव टू search on this particular topic of Nash equilibrium and how to achieve Nash equilibrium and all. So in our upcoming video we are also going to discuss some of the more concept and more variety or more type of the GAN. But for now, if we discuss the solution of these, so you have mode collapse problem in normal GAN. नॉर्मल गैन में मोड कोलैप्स प्रॉब्लम था। सो व्हाट इज द सॉल्यूशन ऑफ मोड कोलैप्स? WGAN. What is this WGAN and all? We are going to discuss in our upcoming further video. But if you, for sake of understanding, you can also read the paper of the WGAN, or there is some much more very good articles and blogs present on the topic of WGAN. That's how WGAN solve the problem of the mode collapse in GAN. So you can explore those things. So this is all about the today's video. We'll discuss the problem associated with the GAN. The first problem is vanishing gradient problem. How we can solve vanishing gradient problem? By minimize generator loss function log of d of g of z. Again, how we can convert from that particular loss to this loss, we are not going to discuss the mathematical terminology, but yeah, this is the thing. Second problem is mode collapse, and the third problem is Nash equilibrium. It is difficult to achieve a Nash equilibrium in GAN. So what is the problem of mode collapse? How we can solve? We can solve using WGAN. This is all about today's lecture, the problem associated with the GAN. And then in our upcoming video we will discuss some more varieties of GAN and some more discussion in the topic of GAN. Thank you very much for watching this video. मिलते हैं नेक्स्ट वीडियो में। टिल देन बाय बाय। स्वस्थ रहे, मस्त रहे, अपने अपने काम में व्यस्त रहे।